Alright, let's go and take a look at our warm-up here. Oh, I shouldn't freeze this. Alright, so our warm-up again is just to review what we did last unit where we were simplifying polynomials that were being divided. So for number one, how do we go about doing number one? What do we have to do? Yeah, when we have same bases, we subtract our exponents. With our numbers, though, we actually just reduce it. Yeah, we divide it. Good. So what does 8 over 12 reduce down to? Good. 2 over 3. They're both divisible by a factor of 4. So 8 divided by 4 is 2. 12 divided by 4 is 2. All right, what about x to the 4th over x? X to the 3rd. Good. Where is that located? Numerator or denominator? Numerator. Good. X cubed. It's a positive 3 when we subtract 4 minus 1, so that stays on top. Alright, what about y squared over y squared? What is that? It's not 0. 1. Good, it's 1. We don't need to write that in, though. So those simplify, they reduce to 1. And then what about z to the 6th over z to the 8th? Z to the 2nd. Yes, where is that located? That's at the bottom. Very good, Carol. Because 6 minus 8 is negative 2, which means it gets sent to the bottom. That's good. Right? That's our first one. So we got that one. Everybody get pretty close, but they just made a little mistake. Good. Alright, number 2, it's negative 9y squared plus 27y divided by negative 3y. It's just written in a different way. So we have negative 9y squared plus 27y divided by negative 3y. Alright, so again, we do each individual piece. First, what's negative 9 divided by negative 3? Close. Negative divided by negative is this a positive. And y squared over y? Just y. So 3y. Okay. Now our next term. Positive 27y divided by negative 3y. Positive 27 divided by negative 3, what does that give us? Negative 9. Good. And y divided by y? 1. So negative 9 times 1 is just negative 9. Alright. And it's already in standard form, so that's our answer. Questions on that? Yeah, it's white out. Alright, so now for number 3. Remember, we have to do each individual term. So I have 12 a to the 4th b squared c cubed over negative 6a squared c cubed. Then we have negative 24a squared c to the 4th over negative 6a squared c cubed. Then we have 6a to the 7th, b to the 5th, c to the 8th over negative 6 a squared c cubed. Pretty long one. Let's just take it a piece at a time. 12 divided by negative 6 gives you? Okay, negative 2. A to the 4th over a squared. Second. A to the 2nd. Alright, and then we have b squared. Is there anything I can reduce that with, though? Nope, so it's just b squared. And then c cubed over c cubed? Just 1, so that stays. That essentially goes away. Alright, next we have negative 24 divided by negative 6. Positive 4. A squared over a squared reduces to 1. C to the 4th over c cubed is just c. Alright, now last. 6 divided by negative 6. Negative 1. Good. A to the 7th divided by a squared. A to the 5th. B, there's nothing to reduce that with, so that comes down. B to the 5th. And c to the 8th over c cubed gives me c to the 5th as well. Now, you technically don't need that 1 there. You can just have your negatives. And it's not quite in standard form because power of 5 is larger than power of 2. So we should have negative a to the 5th, b to the 5th, c to the 5th, minus 2a squared b squared plus 4c. That's our final answer. Still pretty long. That's much more. Yeah, we can see. So remember, standard form goes highest exponent down to 1. And you keep whatever sign is in front of your coefficient. Alright, questions on your warm-up. Who got at least 2 out of 3? Who almost got 2 out of 3, but they just made little mistakes? Alright. Okay. So let's take a look at your assignment sheet. It is pink this time around. Okay, so let's see. Is there anyone else that did not get the Okay, so taking a look at our assignment sheet, you can see this. So this is 10B. This is the second half of Unit 10. It's really just mainly factoring. So it's a little bit of a shorter unit as well, not as short as your last one. So we already took our test last class. I'll be talking to some of you about making that up. And then today we're learning about GCF. Anybody remember what that stands for? We talked about last class. Well done! I knew you guys could remember stuff. Greatest common factor. Then we're going to spend time factoring, doing some more factoring, and you're going to have a quiz on factoring, which we do even more, and then adjustment. So this unit is pretty much factoring, GCF. Okay, so that puts our unit test at April 19th, which when we take a look at our calendar, April 19th is Tuesday. The quarter ends Thursday the 21st. So we'll be squeezing this test in. Alright, questions on our piece? Okay. Alright, and let's go ahead and take a look at our notes for it. So these are your notes you should have in front of you. Based upon your homework from last night, you should, and what we did last class, we put a test down. You should have a general idea of how to do this first part here. But greatest common factor, that's what GCF stands for. Let's go ahead and fill that in. Greatest common factor. Greatest common factor. And again, we talked about this last class, but the greatest common factor is basically the largest factor that both numbers have. Those factors. So the largest factor of both numbers. And I think, Philip, last time you were explaining to us what a factor is. Does anybody other than Philip remember what it means to be a factor? How about this? What if I asked you to give me factors of 8? What are 2 factors of 8? 4 and 2. Good. 4 and 2. So a factor is just a number multiplied by something else to give you that. So 2 and 4 are factors of 8 because 2 times 4 equals 8. Okay. So when we're dealing with factoring is just really breaking down that number into its individual factors. Or you can think of it as the opposite of multiplying. We're breaking it down there. So factoring is the opposite multiply. I guess you can think of it, yes, what we're doing though is we're essentially saying 8 divided by what? 8 divided by 2 is 4. 8 divided by 4 is 2. So, yes, the opposite of multiplying is dividing. You're correct. But you can kind of think of it as backwards multiplying. We're trying to break it down into its factors, trying to break it down into those numbers that multiply together to it, and dividing is a tool to break it down, but you're correct. Dividing is the opposite. So let's go ahead and close it. So it's kind of the opposite of multiplying. Okay, so like we said, we can break 8 down into 2 times 4, because 2 times 4 is 8, so 2 and 4 are factors. Now, we've also used the word prime before. Does anybody know what that means to be prime?
Was the factor only one in itself?
Good. So prime means that you can't break it down any more than just one in itself. So what would be an example of a prime number? 1 is prime. Good. Any other examples of prime? 3, 7, 13, 19, 101. Those are all prime numbers. So I could actually break this down even more. Can I break down 2? Well, 1 and 2, right? I'll give you that. I'll do 1 times 2. What about 4? Can I break 4 down? 2 times 2, right? So if I said what is the prime factorization of a number, that means I want to know just the prime factors. So my prime factors for 8 would be 1 times 2 times 2 times 2. 1 times 2 times 2 times 2 gives you 8. So that's what I mean by prime factorization, prime factor. Okay, so let's then just move on to finding some GCFs here. Now again, we did this last class, so hopefully this is a little bit of a refresher for you. So find the GCF of 12 and 30. So we want to first take a look at my factors for each. Alright, so good. 6 times what gives you 12?
2.
Good. What else can I multiply together? 1 and? Good. What else? 4 and? Good. Anything else? Any other integers? We're done. We're done. I think last time we wrote it out like this. Either way, some people like to write out characters like this, and last time we kind of wrote it or went back and forth. 1 times 12, 2 times 6, 3 times 4. I think this way is also helpful because you can make sure that you've covered all your numbers. Because once you hit 4, if you can't do 5, then you don't have to keep checking. 7, 8. Right. Then what about 30? What can we break 30 down into? 2 and? Yeah, 2 and 15. What else? 3 and? 10. What else? 5 and? 6. One more. 6 and 5. 1. Good, 1 and 30. I forget about that. Alright, again, if we were to write it out this way, we have 1 and 30, 2 and 15. And try 3, 3 and 10. 4 doesn't work. 5 and 6. And we've now met our middle there. Okay, so these are all of our factors. These are factors. If I take 2 times 6, that gives me 12. If I take 3 times 4, that gives me 12. If I take 1 times 4, that gives me 12. These are my factors. Alright, so now I want to find the greatest common factor, the largest one that they both have. And what would that be? 6? Yeah, I agree. Over that they do have 3 in common, so that would be a common factor, but not your greatest one. Yeah. Alright, so my GCF equals 6. Okay, let's take a look at 8, 24, and 36. Now, Miss Charlotte made a note last time, which I thought was really good. She said as you get better at these, a shortcut that you can use is taking a look at your smallest factor, or your smallest number. Because if I look at my factors for 12 and 30, 12 is not going to have a factor larger than itself, right? So I already know that 30 is not going to be one of my common factors because that's bigger than 12. You can't multiply 30 by another number to get 12. I also know that 15 is not going to be a factor of 12 because you can't do 12 times another integer to get 12, or 15 times another integer to get 12. So a hint that she gave last time was try to see if your smallest number is a factor of 12, and then go from there. So actually, let's go ahead and write out our factors for 8, right? That's my smallest number. So what are my factors for 8? 2 and 4. 4 and 2, what else? 1 and 8, yeah. These are my only factors. Okay, so let's start with the largest one. Is 8 a factor of 24?
Yeah.
Yeah? Is 8 a factor of 36? 36 divided by 8. What is 36 divided by 8? Yeah, decimal, right? It's not an integer. So that's something to make note of. Factors are always integers. Okay, so 8 was a factor for 24, but not also a factor for 36, was it? So 8's not going to work. Let's try our next largest number. What's my next largest? 4. So is 4 a factor of 24? 4 times what gives you 24? 6, good. And is 4 a factor of 36? 4 times what gives you 36? Good, 9. So 4 is actually going to be my GCF, my greatest common factor. See how that saved us some time? We didn't have to list out all of the factors of 24 and all of the factors of 36. So let's recap what we just did there. So we took our smallest number, because I know I'm not going to have a GCF bigger than my smallest number. Does that make sense? I can't have a factor larger than the number itself. So I took my smallest number and I broke it down into its factors. Since I want the greatest one, I'm going to test my largest one first. I'm going to check to see if this is a factor of 24 and if it's a factor of 36. If it's a factor of both, that's going to be your highest common factor. If it does not work for both, then you check your next one. So it's kind of like over here. If I would have checked 12, I would start off at 12. Does 12 go into 30 even? Nope, so it can't be 12. So then check my next highest one, 6. Does 6 come to 30? Yeah. So since it cannot be it cannot be larger than the number itself. It has to be one of its own factors, and we want the largest one, so we test our largest one first. All right. Just so that we can test this method again that we just did here, let's say, 27 and 36. Okay. I'm just making up a new problem here. All right, what are my factors of 27? 3 and 9. What else? 1 and 27. Okay, so let's try our largest factor. Is 27 a factor of 36? No. Right. Is 9 a factor of 36? I heard no and I heard yes. Those of you that say yes, what is it? 9 times what gives you 36? 4. We just did that one, right? Good. So 9 is a factor of 27, and it's a factor of 36. 9 times 4 gives you 36. Good. So 9 is actually my GCF. It was a little bit faster. Does that make a little more sense? Awesome. Okay. Questions before we move on to our variables? Okay. So now let's take a look at our variables. What do you think is the GCF for 4 and 6? 2. Good. Okay, so my GCF, we want to do our numbers first. 2. Now, with my variables and exponents, I'm actually going to have the smallest exponents, the variable with the smallest exponent. So which one has the smaller exponent? Good, so it's actually going to be 2x squared. The reason for that is if I break 4x cubed down, this is 2 times 2 times x times x times x. If I break down 6x cubed, 6x squared, this is 2 times 3 times x times x. What all do they have have in common? 2's, x, and x. So 2x. That's where that comes from. If that helps you to do it that way, feel free to do so. If you are good with the numbers but you struggle with your exponents, just draw out your x's and circle how many you have that are the same. But it's always going to be the smallest exponent. So then let me ask you this. What if I asked you to find the GCF of 2x to the 5th and 10? Let's say I asked you for that. What is your GCF of 2 and 10? Does 2 go into 10? Yeah. So GCF of 2 and 10 would be 2. Do I have any variable though? No, because if I look at my variables, we have x to the 5th, and there are no x's over here. So that there are no x's in my GCF, because it has to be in common. They both must have it. 10 doesn't even have any x's at all whatsoever, so it can't be a part of your GCF. X isn't a factor. Okay. Questions on that? Yeah.
What if you get two numbers that don't have anything in common except one?
That's a great question. So if we have two numbers that have absolutely nothing in common other than one is your greatest common factor. Yeah. That's a good question. So if we had like 3x to the 5th and 10, your GCF would be just 1. Very good question. Other questions? Okay. Let's move on down the page. So when we find the GCF of a polynomial, it's like undoing the distributive property. It's like undoing the distributive property. So let me show you what I mean by that. Let's say I had 2 times 3x plus 4. When I distribute this out, what do I get? 6x plus 8. Alright, well now let's find my GCF of 6x and 8. What's my GCF of 6 and 8? 2. And can I do a GCF of x and O? No, so what's my GCF? Oh, look! GCF is 2. That's what I distributed. So if I take a 2 out of 6x, what's 6 divided by 2? What's 6x divided by 2? 3x. Okay. If I go back to what I just did, 6x divided by 2, what we were doing above, 6 divided by 2 is 3, and we said for x. And then what is 8 divided by 2? 4. Oh, look! We just did the opposite of the distributive property. So factoring, again, is the opposite of that. Distributive property is just multiplying. Factoring is the opposite of that. You're undoing that. You're pulling out that factor. Alright, so we're going to today look at just taking out the GCF. Next class, we're going to take a look at completely factoring it down to its individual factors. Alright, so when finding the GCF, look for 3 things. First, you want to look to see, is there a negative in front? So our problem needs to be written in standard form. So if it's not in standard form, always put in standard form first. Then you need to see, is there a negative in front? Does your leading coefficient have a negative sign? If so, factor it out. So for example, number 2, what's your leading coefficient? What's that number in front? For number 2, what's my leading coefficient? -3. There's a negative in front, so I need to take out that negative. Anytime we have that negative in front, we need to factor out that negative. Alright, so not only do we need to look for negatives, but we need to find with my GCF the largest factor of the numbers. So the largest GCF of the numbers. Actually, let's use a more mathematical term. What are these numbers in front called? Coefficients. Good. The largest GCF of the coefficients. So since we already made mention of this negative here, let's go ahead and kind of work through it. Since there's a negative in front, I need to pull out that negative with my GCF. Now let's take a look at what's the largest GCF of my coefficient. So I have a coefficient of 3, 6, and what's my coefficient for this last term? Good, -1. So looking at 3, 6, and 1, what's my GCF of those? Close. 1. So 3 is a factor of 6, but is 3 a factor of 1? No. So 1 is the only thing that all of them have in common. Okay, so that comes out. And then the last thing we need to look for is, our variables. When you take a look at our variables with the lowest exponent. So the variables in common. And remember, we can only factor out the variable with the smallest exponent. Factor out the smallest exponent. So for number 2, do they all have x's? Yeah, they all have x's, but what's my exponent? What's the largest amount I can take out? Just 1. Good, just an x. So for this, the GCF, my greatest common factor, my GCF is -1x, or just -x. Okay? So of these 3 terms here, my GCF is -1x. Yes?
What number doesn't have?
Then you can't take out the x. So like number 1, I can't take out an x. There's no x on the end. Good question. Question so far of what that means with the GCF? Okay, so now the trickier part. So we found our greatest common factor. We just did that. And it says, and factor it out. So now we need to do that undoing of the distributive property. Okay? So if I take out... So if I take out a -1x, we always write that in first. Okay, then put parentheses. So -1x parentheses. And I should see everyone writing this down. Alright. So now you need to ask yourself, what -1 times what gives you -3? Good. Or you can think of it this way. -3 divided by -1 is 3. Okay? X times what gives you x cubed? Yeah, x squared. Or you can think of it this way. X cubed divided by x is x squared. Let me repeat that. I want to make sure we're all on the same page here. So I have taken out a -1 and I've taken out an x. So I'm looking at just my term here. So I'm essentially saying -3x cubed. I'm taking out a -1 and I'm taking out an x. -3 divided by -1 is just 3. X cubed divided by x is x squared. So I've taken out a -1, I've taken out an x. Right? So now we're going to do that with my next term. So positive 6x squared. What is 6 divided by -1? -6. And x squared divided by x? Again, notice, I had x squared, I took 1 out, so there's only 1 left behind. I had 6, I took out a -1, so 6 divided by -1 is -6. Alright, now finally my last term, -1x. What is -1 divided by positive 1? And what's x divided by x? You go through all 3 of your answers. What's x divided by x? 1. Anything divided by itself is 1. Think of it this way. I had an x. I took out the only x that I had. There are no more x's left behind. So what I have is negative 1x times 3x squared minus 6x plus 1. So my GCF is what's hanging out in front. Everything else is exact. So this is actually, I factored out for it. So I found my GCF here, and then I factored it out. Questions so far on this? Okay, so remember, factoring is undoing the distributive property. All right, it's kind of like opposite of multiplying. So let's go ahead just to check to make sure we did it right, and sometimes the instructions will tell you this. Let's go ahead and distribute it back out, see if we get the same thing. So if I were to distribute this, what do I get? What's negative 1x times 3x squared? Okay, negative 3x cubed, so negative 1 times 3 is negative 3. X times x squared is x cubed. Alright, what's negative 1 times negative 6? Good. And x times x? Good, x squared. And what's negative 1x times 1? Oh look, does this match what we have up here? Perfect, that means we did it right. So that's all that we're doing. We're taking it all multiplied out, and we're factoring back out that GCF. It's the opposite of distributive property. So you can do that to check to make sure you did it right. You can even do that in your head if you want to. Negative 1x times 3x squared should be negative 3x cubed. Perfect, got it. Negative 1x times negative 6x should be positive 6x squared. Perfect, got it. Negative 1x times 1 should be negative 6. So we're just undoing that distributive property.
Some things that are untimed, like the SOL, you should be doing that to check the work.
Alright, questions on that one? Okay, so let's try number 1. Number 1 actually might be a little bit easier, but I wanted to show you one with the negative in it. You still right there? Alright, so negative 1. Or sorry, not negative 1. Number 1. Alright, taking a look at my first of all, is there a negative in front?
Yeah.
Actually, before I ask that question, is this in standard form? Yeah, it's in standard form. Is there a negative in my leading coefficient? In the leading coefficient, the very first. Nope, so we don't even have to take out the negative. Which, over here, this might make life a little bit easier for you if you understand this. When I factored out my negative, what did that do to each of my signs?
Opposite.
Yeah, it changed them. Because remember, a negative times a positive is a negative. A negative times a negative is a positive. So when you factor out a negative, all it does is just change your signs. So that might help you out too. Okay, so there's no negative to factor out. So let's look at our numbers. Of 2, 4, and 8, what's my GCF?
2.
Good. 2 goes into both. So I'm going to, let's first state our GCF. I'm going to write off to the side. Okay. Now, do all of them have x's? No, so I can't take out an x. So the only thing I can factor out is 2. I cannot factor out an x because 8 doesn't have an x. Right, so we factor out our 2. So let's write our GCF in front and our parentheses. Alright, 2x squared divided by 2. What is that going to leave behind? Good, just an x squared. And it's fine if you write the 1 there. Good, so 2 times x squared is 2x squared. Perfect. Alright, 4x. We factored out a 2. What's left behind? Positive 2. Because remember, I didn't take out a negative today. So the signs stay the same. 4 divided by 2 is just positive 2, and I still have my x. Again, we can look at it. I had 2x squared. I took out that 2, so I don't have any more coefficient part. 2 divided by 2 is 4. 4x. I took a factor of 2 out of there, so there's only 2 left. 2 times 2 is 4. Alright, negative 8. Factored out of 2. What's left behind? Negative 1. Good. Because you're right. 8 divided by 2 is 4, but we have that negative. Good. That's our answer here. Now let's double check it. If we were to distribute it back out, get 2x squared plus 4x minus 8. Does that match? Yeah, good. So this is definitely my answer. And it's perfectly fine to go ahead and multiply it back out to double check, but just put a box around your answer so we know what we're doing. Questions on that? Alright, show me thumbs up, thumbs middle, thumbs down, how you feel with this so far. Okay, so let's start off with a little bit of an easier one. Let's have you do, let's see. Yeah, I want you guys to go ahead and try number 8. Let's just even get the basics of it. Once you think you have 8, try number 10. So I want you to first do 8, and then do number 10. If you have questions, feel free to ask the person next to you, and I'll be coming around to answer questions as well. Alright, let's take a look at number 8 together. You guys are doing good with the numbers, but we're struggling some with the variables. Alright, so between 2 and 6, what's my GCF?
True.
Good. Alright, so we took care of our numbers, but what about our variables? X squared and x cubed. What's my GCF of those? X squared. Good. The smaller of the two exponents. So my entire GCF is 2x squared. So we write that off to the side. Now let's go ahead and factor out 2x squared. Take a look at your first term. I'm going to cover up my second term. 2x squared divided by 2x squared. So 2 divided by 2 gives me 1. What's x squared divided by x squared? Anything divided by itself? 1. So 1 times 1 is just 1. If I multiply this back out, 2x squared times 1, what is that? 2x squared, right? 2x squared times 1 is just 2x squared. So that's my first term. So I took care of this. Alright. Now, negative 6 divided by 2. Negative 3. Good. And x cubed divided by x squared? Just x. If I have x cubed, that's x times x times x. Well, how many did I take out? I took out both of these guys. How many x's are there? Yeah, it's just an x there, just x to the first. Just like with my negative 6, I have 6. 6 is 2 times 3. Well, I took my 2 out, so all I have left is 3. So you can think of it that way. 6x cubed is 2 times 3, x times x times x. I took out my 2, I took out an x, and another x, so all that's left behind is 3x. That's what we're doing each time. We're essentially dividing there. Okay. So if I were to multiply this back out, if I were to multiply this back out, 2x squared times 1 is itself 2x squared. Then 2 times negative 3 is negative 6. X squared times x is x cubed. So this is my answer here. Questions on that? Yes.
But I thought the variable was supposed to be positive.
Only if you factor out a negative. So on our first problem that we did, we factored out a negative here, and I said when we factor out that negative, that ends up changing each of my signs.
So it has to be like the first one.
Yeah, so when the very first term has a negative, then I factor that out, and that will change all your signs. Whereas here, in problem 1, there was no negative part, so I didn't need to factor out my negative, and thus my signs stayed the same. Good question. Alright, other questions on this one? Okay, raise your hand if you got the GCF of 2. If you at least got the 2. Good. Keep your hand up if you also got your x squareds with it. Good, good. Alright, so let's take a look at 10 then. Okay, let's write out my GCF. First of all, Actually, I didn't even ask this for the last one. What should we have done with the last one before we started? Yeah, we should have put it in standard form. Which, it's okay. We can fix it now at the end. So I have my 2x squared in front. This piece here, how would this change to be in standard form? Good, negative 3x plus 1. So, no, this is technically considered. So if you forget in the beginning, you can fix it in the end. But I should have checked that in the beginning. My apologies. Okay, so is it in standard form? Yeah, good. Now, do we have a negative in front? Yeah, so we have to take out that negative. Okay. Now, looking at our numbers, 27, 18, and 3. What's my GCF? Yeah, the 3. The smallest number ends up being a factor of all of them. So, okay, do they all have x's? So what's the factor I can take out? Okay, we can take an x out with it. Because the smallest exponent, 3, 2, 1, is going to be our 1 here. Alright, so my GCF ends up being negative 3x. And again, we only take out that negative when in standard form it has a negative. Alright. Now the nitty gritty. Let's write our negative 3x in front. And let's take it one piece at a time. Okay. Now we said the negative changes our signs, right? So this is going to become positive. What's 23 divided by 3? Good. X cubed divided by x? Good. Alright, again, it changes my signs. If you want to just go and fill in your signs, that's fine. Might make it a little bit easier for you. Alright, 18 divided by 3. And x squared divided by x. Good. Again, I had x squared, I had 2 of them. I took 1 out, so there's only 1 left. In the beginning, I had x cubed, 3 of them. I took 2 out, so there's only 1. Or sorry, I took 1 out, so there's 2. Alright, and what do you think my last term is going to be? Yeah, 1. So let's double check this. I multiply it back out. Negative 3x times 9, negative 27, x cubed. Negative 3 times 6 is negative 18, x squared. And negative 3x times 1 is negative 3x. That work? So that's our answer there. Questions on that? Alright. Let's take a look at some of these harder ones. Okay, what do you guys want to do? Which one do you want to make easier? 6 and 7. 11. So 6, 7, 11. We'll go in that order.
What about 5?
Let's do 6 and 11, then we'll come back and see what we have. Ah, I like 11. Alright, I'm glad you said... Oh, were we the one that said 6? I thought you said 6. Alright, is this in standard form? Yeah, they all have an exponent of 4, right? What's going on here? What do we see about our variables?
None of them are alike.
Yeah, they're all different variables, aren't they? So it's in standard form because the highest exponent is 4, and since they all have 4, we just go alphabetically, X, Y, Z. Okay, so it's in standard form. Is my leading coefficient negative?
Positive.
It's positive, so I don't need to worry about a negative. 8, 6, and 9. What's my GCF of 8, 6, and 9?
1.
1. Yeah? Do you agree?
Yeah.
It's kind of weird, isn't it? Why is it 1? So let's take a look. What's my smallest number of these? 6, right? Okay, so let's take a look at my factors of 6. We have 1 and 6, 2 and 3, and that's it. So does 6 go into 9? No. Does 3 go into 9?
Yeah.
Yep. Does 3 go into 8 though? No. Does 2 go into 9? No. We're only left with 1. So 1 is the only thing that they all have in common. If I wrote out my factors for 8 and 9, we have 1 and 8, 2 and 4. So 8's not in common, 4's not in common. Let's write our factors for 9 would be 1 and 9, and 3. Well, 2 doesn't exist in all of them, and 3's not in all of them. The only one that they all have is 1. It's the only number they all have in common.
Please remember they have to go on all 3 of them. I see
Mhm.
that's a very common mistake. If it goes to 2, then we take it out. It has to fit in all of them.
If I gave you 20 different numbers, it would have to be a factor of all 20 numbers. Oh, wouldn't that be a fun problem?
Oh,
Yeah.
I like the.
I don't need to let you share. Okay, so my common factor, my numbers is what? Now, here comes the tricky part. Do they all have the same variable? No. So do they have any common variables? No. So can I take any variable out? No. I can't take out an x because these don't have x's. I can't take out a y because these don't have y's. And I can't take out a z because these don't have z's. Remember, GCF is greatest common factor. They all have to have it in common. So there's no variable they have in common, so my GCF is just 1. So you'll like these ones because when I have a GCF of 1, the only thing I could do, it stays the same, right? So whenever you have a GCF of just 1, for your homework tonight, if you have a GCF of just 1, you honestly don't even need to factor it out like this. You can just say GCF equals 1 and stop there. Because it's kind of pointless to do this. This right here is kind of pointless. So for now, when you have a GCF of 1, just say GCF equals 1 and then you're done. Okay? Because we don't factor out GCFs of 1. When we do our factoring tomorrow, when do I see it again? Monday? When we do our factoring on Monday, you'll see that we don't take any GCF of 1 out. That's what we just did. Okay, so 6 was done. What was next? Was it 7? Ooh, this looks good. All right, number 7. Let's start off with our numbers. My smallest number is 12. Okay. Well, actually, first of all, is this in standard form? No. My largest exponent, yeah, b is 5. That's the largest of all of them, right? So let's rewrite this in standard form. 36a cubed b to the 5th. Then we next have our exponent. So my highest exponent was for my b, so my next highest exponent would be 4. So negative 54 a to the 4th b to the 4th. That's what this is. Go away. Alright, then my last one is the 12 a to the 4th. Okay, so when I look at my numbers here, what's my smallest coefficient? 2? Coefficient, the number in front. Okay, 12. So my GCF has to come from here, right? So can 12 go into 36? Yep, I agree. Does 12 go into 54? Check it out. Does 12 go into 54? It's 54 divided by 12. 4.5, so that doesn't work. Okay, so what are my other so we have 1 and 12, 2 and 6, 3 and 4. Alright, so 12 didn't work. Let's try 6 next. Does 6 go into 34? Yep. Does 6 go into 54? Yeah. What is 6 times what gives you 54? 9. Good. So 6 works. Alright. So 6 is going to be part of my GCF. There's no negative part, so we don't need negative. Now for our variables, we have to take a look at both variables. Do they all have A's? Yep. What A can I take out? A to what? Good. Yeah, the smallest one would be A cubed, so good. A cubed. Alright, do they all have B's? Good. And what's the smallest exponent for my B's?
B3.
Yeah, also B cubed. Okay, so my GCF is 6A cubed B cubed. Right, but remember this, I can only take out the smallest one. Because B to the 5th is like this. B to the 4th is like this. And B cubed is like this. So the most that they all three have in common would be B cubed. Okay, so, you know, sometimes it looks a little intimidating when you have a large GCF. But what's nice is the larger your GCF, the smaller these become. They usually get a bit smaller. Alright, so we have 6A cubed B cubed. Alright, 36 divided by 6. What's 36 divided by 6? A cubed divided by A cubed?
No A.
1. Anything divided by itself is 1. I'm going to start making you guys chant that. Alright, B to the 5th over B cubed? Good. So we have left behind 6B squared. This is a bit smaller. Alright, negative 54 divided by 6. What's left behind? What kind of 9? Good. A to the 4th divided by A cubed. What's left? Good. B to the 4th over B cubed. What's left? Good. A little bit smaller. Great. Last. 12 divided by 6. What's left? A to the 4th over A cubed. What's left? And B cubed over B cubed? Just 1, right? There's no B's left. Alright. That's our final answer. Double check it. It gives us 36 A cubed B to the 5th. Negative 54 A to the 4th B to the 4th. And 12 A to the 4th B cubed. Yeah. So that's our final answer. So notice again, this is more complicated out in front, but the inside became a little bit more simple. Alright, number 11. First of all, questions on this? Alright, number 11. Alright, is it in standard form? Yes. Is there a negative in front? That's the old negative. So he's going to be coming out. And taking a look at my numbers. What's my smallest coefficient? 2. Good, negative 2. So, can 2 go into 12? Does 2 go into 23? No. So, what has to be my GCF with the numbers? 1. Good. Pick 1. Do they all have X's? No! You think they do at first, but who's missing their X? 12. So, can we take out an X?
No.
No. So, there's no X's I can take out. So, my GCF is just negative 1. So this is an interesting one. We have our GCF here. If I take out my negative 1, what's the only thing that's going to change to my inside?
The positive.
They change from negative, positive, positive, negative, right? It only changes my signs. So what's on the inside then? What's left behind? 2x cubed plus 3x squared minus 23x minus 12. So the other thing we could do was factor out that negative. And you must factor out the negative if it's in front. Now, you can either write it as negative 1, or you can just leave it as a negative in front. Either way is perfectly fine. And think, if you were to distribute this negative, think back to the last unit where we had to subtract polynomials. We distributed our negative, right? If I distribute my negative, we see it ends up just changing the sign. That one actually isn't bad. Questions on that one? Okay. What was the other one you guys requested? Nothing? 5?
Yes.
Alright. Is this in standard exponent form? Yeah. The highest exponent is 2. They all have it, so we go alphabetical ABC. So is there a negative to take out? Yep. Okay, woo! Looking at my numbers here. We have 81, 63, and 72. Isn't this a good time to take our shortcut method? What's the smallest number? 63. Let's break down 63. Alright, obviously 1 and 63. 3, so 2 doesn't work, right? So 3 and what else? 3 times what gives you 63? 21. Good. 63 divided by 3 is 21. Alright? 4 work? No. Since this is an odd, none of my even numbers are going to work. So 4 won't work. Does 5 work? No. 5, multiples of 5 actually always end in 0 and 5. That's another shortcut. What about 6? 6 work? 6 times what gives you 63? Does 6 work? Doesn't work, does it? Okay, so 6 didn't work. What about 7? Ah, 7 and 9. And we know 8's not going to work, so we don't even have to check that. Alright, so here are factors. 63 going to work in 72? No. Does 21 work for 72?
No.
You have the calculator, right?
No.
Check on your calculator. 72 divided by 2. It's a decimal. So it didn't work. So 21 did not work. Does 9 work for 72?
Yes.
Yeah, 9 times what gives you 72?
Oh.
Come again? Good. 9 times 8 is 72. What about 81? Does 9 go to 81?
Yeah.
Yeah, 9 times 9. Good. So we found our GCF. A lot faster than writing out all our factors. Alright, so we have 9. Okay. What variables do they have in common? Y squared. Good, and that's the only thing they have in common of their variables. Okay, so negative 9y squared. Okay, what does that negative do to my signs? Changes all of them, so that becomes positive, negative. Alright, 81 divided by 9. And what's left behind of my ay squared? Just the a. I took out my y squared, right? So all that's left is my a. Okay, 63 divided by 9. 63 divided by 9. 7. What'd you say? 7b. Good, because my y squared I already took out. Alright, what about my last term? 72 divided by 9? 8. And what else is left? C, because I already took out the y squared. Good, and that's your final answer there. Alright, questions on that? Okay. Let's take a look at 3. Alright, so I want you guys to now do 3 and 4 with the person behind / in front of you, so the person next to you. And Aurora, you just work with those 3 or those 2 lovely ladies. So Jaylene, Phillip, Natalie, Drew, and then Gerardo, Aubrey, Freddie, Jose, Kevin, Katya, Adriana, Jonathan. You guys look so thrilled. Rachel, Brian, Aiden, Jason. I'll be coming around to help out. Do 3 and 4 with the person that I just told you to work with. Do we still have 9 to do? Okay, 3, 4, and 9. I apologize. I didn't realize there was one more. 3, 4, and 9. And then we're going to come back together and go over those. So 3, 4, and 9 with the person I assigned. Alright, you guys are doing pretty good with these. So let's take a look at it, make sure we're getting it. Alright. What was your GCF for number 3? 7x squared?
Squared.
Good. So when we factor out 7x squared, should have gotten 6x to the 6. Good. Negative 2x to the third.
What?
It was fifth. It was fifth, but then we took out an x squared. Alright, then plus x squared or 1x squared, good. Plus 10. Oh, just 10.
Got it.
Good. Good. Alright, is my number 4 in standard form?
Yeah.
Yeah, so what's my GCF?
3x squared.
Good.
Nice.
You said it so quickly, I didn't have it written down. Okay, negative 3x squared. Awesome. Alright, you need to take out that negative with it. So that's going to change all my signs here. So I have 2x to the fifth. It was 7th, but we took out x squared. Then minus x squared, then plus 5. Good. Questions on that? Awesome. Alright, last but not least, number 9. Ooh, some big numbers here. What's my, first of all, is this in standard form? Good. What's my GCF? 4y. Good. So if I factor out my 4y, I have 4y squared plus 20y. Good. Minus 25. Good. Well done. Very good. Awesome. Okay, we have about 5 more minutes left. I'm going to go pass out your homework to you. You can probably knock out a couple of them before the bell rings. It is my expectation you are working on it until the bell rings. So let me get that for you. Your homework is worksheet 3.